All right. What have we been working with? Rational numbers, haven't we? Okay, fractional numbers is a fraction. So today we're gonna work with exponents that are fractions, okay? So we're gonna work on these objective, rewrite radical expressions using rational exponents, okay? We're gonna simplify some also. So what does that look like? That would look like x to the 2/3 power. Haven't had many of those. It's a fraction. Exponent is a fraction. X to the 2/3 power. We could write that as a cube of x squared. Okay? So we're going to go back and forth between writing it as a fractional exponent and writing it as a radical. The denominator part, whatever the fraction, it becomes this guy right here. And whatever we have on the top comes inside as our multiplier. You might want to jot that down. I have it coming up later, but you can look at it again. Another example, we could have x to the 4/3 power. That would be the cube of x to the 4th. That makes sense to you? So this will be a new first for you, and that is fractions as exponents. Make sense? Fractions as exponents. So I would liken it to when we did logs. You know, we had to go back and forth between the log form and the exponential form. Okay? We're going to need to do that some here. This would be fractional exponent. This would be in radical form. Okay? So you're going to need to be able to simplify those and go back and forth. Your calculator can help you. It can simplify rational exponents pretty good. So that is an option. So if you have one handy, it might not hurt to pull that guy out. All right, everybody okay? Let's move on. We're going to try a couple of simplifications. Just to review, simplify. Okay, remember the index there is 4 on this first one, letter C, letter A. Okay, so that means we need sets of 4. Let's do this first one together. So 81 would be 9 times 9. That's only a set of 2 9s, right? So, but I need 4. Well, 9 would be 3 times 3 times 3 times 3. I have a lot of x's here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So this is still the 4th root of all that stuff. Now, I wouldn't suggest writing them all out this long. I'm just doing the first one. Now, we need sets of 4. There's a set. There's a set. There's another set. And there we go. And there's nothing left over, is there? So basically, this simplifies to 3x, 1, 2, to the 3rd. So whatever the index is, that means we need that many of those things would underneath the radical to come out. See what you can do with letter B. What do I need? Sets of what? Sets of 3. Okay? Sets of 3. Do I have any sets of 3s and numbers? 27 would be 3 times 3 times 3. That worked out good. And I have a bunch of x's, enough to take out. So that answer here is going to be 3x squared. Was there anything left over? No, we were good to go. Now, if this happened to be a 7, then it'd be the cube of 7 left over. It's cube of x, I'm sorry. 7 there. Cube of x would be left over. Does that make sense? I hope it does. And we had that one extra one, so we have to rewrite it like that. But we didn't. And it worked out exactly as that. questions there? Now, this next one is a little bit trickier because it's a cube, of course. Okay, so we're going to take the cube of x cubed over the cube of 7. We can write that as it's a fraction. Well, the cube of x cubed is what? That's good, that one's easy, x. Over the cube of 7. Now, we have to rationalize. This will be the first time in your math career you rationalize a cube, not a square root. Okay? A cube root. So there's a couple ways to look at this. Since I need 3, I can do it 1, 2, 3 times. Or I could rewrite this, and this might help you, as the cube of 7 squared. Why? Because I need a set of 3, not 2. Okay? Up here, we'll write it as the cube of 49. Is the cube of 49 and the cube of 7 squared the same? Yes, they are. Okay, so now I have x, cube of 49, which I can't do anything with. Underneath, I'm going to have the cube of 7 to the 3rd, right? But what is the cube of 7 to the 3rd? 7. So now my answer is going to be x cube of 49 over 7. Now, they're still the same, okay? They mean the same thing. We just changed how they look. We changed by rationalizing. What did we rationalize? We rationalized a cube, not a square, which is a little different. Questions there? All right. Here's what I showed you already. How we can, in algebraic form, 16 to the 1/4. We write that as the 4th root of 16. We can simplify that. The 4th root, 16 would be 2 times 2 times 2 times 2. Take out, and that would be simplified to 4. Also, you can look at it algebraically here. I like this one. Any a raised to the mn. Okay, there's 2 options here. It can be n to the am, and we can also write it as n a, and then you can have the m outside too. It works the same. So you're going to have to go back and forth between those, writing it as a fractional exponent. So what is it? What are we talking about? Talking about exponents that are fractions now. Remember when we add fractions, we have to do what? Have the same denominator, don't we? When we multiply fractions, we can just multiply straight across. So multiplying is a lot easier than adding fractions. All right, write the expression negative 32 to the 3/5 in radical form and simplify. So first of all, try to put it in radical form. So radical form, 5 is going to be my index. I'm going to have negative 32 to the 3rd power. You can also write it this way, 5 index, negative 32 to the 3rd power. Those are both okay. You see that? Okay? Now, the cool thing about some of these rational exponents is that I can use my calculator, grab it real quick. Put negative 32, use your caret. I might put a bracket, 3 divided by 5, see if you can pop out, you should pop out negative 8. That's the answer. How we doing there? Get that one? So your calculator can help you with some of these, okay? Which would be fine. We could also write this as the fifth root of negative 32 times negative 32 times negative 32. 32 is a bunch of twos. In fact, 1, 2, 3, 4, 5. They're all negative here. So we got 5, 5, and 5. 2 times 2 times 2, negative 2 times negative 2 times negative 2 would be negative 8. So there it is the long way also. Try another one. See if you can simplify that. You can do it, write it in the expression, and then you can also use a calculator. You say 64 to the 1/3 power. But I am going to ask you to put it in radical form first. Hopefully feeling a little already good about that. That'd be the cube of 64. We need sets of 3. 64 happens to be 4 times 4 times 4. So there's our set of 3. And here, simplify it to 4. Here it is in radical form. Here it is simplified. Woohoo! How we doing, my friends? Okay? Everybody okay? Questions at all? Keep rolling. One more of these. See if you can write it in radical form. Remember, this is like we got to go back and forth between these two forms. See if you can write it in radical form. Oops. Now, notice I didn't put the 2 there because we don't have to, all right? It's always understood to be a square root. So, this is really the square root of 4 times 4 times 4 times 4 times 4. We can put 2 there if you want. Need sets of 2. 1, 2, but 4 can be 2 times 2. Another set, so this thing really ends up being 4 times 4 times 2. 432. If you want to grab your calculator and put 4 to the 5/2 power, you should get 32. How do you feel about fractional exponents? A little better, okay? You sure? Now we're going to start adding them and multiplying them. Remember if we had x squared times x to the 5th, what would that be? X squared times x to the 5th. What are you doing here? Same base, what do you do that for? You add them, that would be x to the 7th. So if I had x to the 1/2 times x to the 1/2, I'm going to do what to those exponents? I'm going to add them. So this really ends up being x to the 1st, doesn't it? 1/2 and 1/2. So all the powers, or all the things that products do hold the same, okay? There you go, write those in. Going the other way now, I'm giving them to you as radicals. See if you can write them in rational exponents and simplify. Now the cool part there is that we can simplify those fractions pretty easily. right, so we can rewrite this as what? 13 to the 13 to the what? Okay, which will be what? 13 to the half. Letter B, what do you think? 13 to the? Letter B, 13 to the third, okay? So it would be 13 to the 15 over 5, which is 13 to the third. Okay, so as I was expressing to you a second ago, all these properties hold true, the power, okay? The quotient, remember if we had x to the third divided by x to the second, okay, we could bring this up and say x to the third minus 2 and end up with x to the first. Or some of you can think about canceling. We're going to do that same thing with fractions. But remember, when you add fractions, you got to have the same denominator, okay? Now, we could say x squared and raise it to the third. We multiply there, and that would be x to the sixth. Well, when you multiply fractions, remember how you multiply fractions, okay? If you had 1/2 times 1/3, that would be 1/6. You just multiply straight across. So I'm telling you that you're going to get confused. When you multiply a fraction, you just multiply. When you add them, you're going to need to get the same denominator. Try to keep that in mind, okay? So all these properties that you've already used many times apply. So here's one that I want you just to look at. So we have 7 to the 7/9 times 7 to the 11/9. Now, fortunately, 9, I have the same denominator, right? So we're going to add those. I did skip a little step here because it's really 7 to the 18 over 9, right? Of course, 18 over 9 goes to 7 to the second, and then we write that as 49. Questions there? All right, take a shot at one. There's a division that's going to be 16 to the 3/4 minus 5/4. We're going to bring it up, see if you can simplify that on out. Negative exponents are not allowed. You're going to have to do something with that. What do we end up with? 16 to the what? Is it positive half or negative half? It is negative half, okay? So if I want to write that as a radical, could I? Maybe. Can you simplify this on out? Okay, I'm going to write it as a positive exponent. It's going to be 1 over 16 to the half. Okay, remember negative exponents aren't going to go. How do we get rid of negative exponents? We move them between numerator and denominator. Remember that? Okay, now I might want to rewrite this as, and it might help you think about it, 16 would be the square root of 16, right? It'd be 2 here and 1 here. Well, now if you write it that way, most of you have recognized that to be what? 16 to the half, you recognize that to be what? 4. It's the square root of 16. So if you see half, that means the square root. So what's this whole thing end up really simplified to? 1/4. Rational exponents All the same properties we usually do. Good, John?
Yeah.
Yeah, I can tell. Take a shot at some of those homework problems, check them as you go. This is the initial part, okay? That I'm asking you to try to do these problems because you have to be able to handle this part to do the next couple parts that's even harder. This is like the basics, the fundamentals of handling rational exponents. Do you understand what I'm saying? I want you to check your answers as you start to do them, so there you go.